All right, for this problem, we're going to factor this by grouping. And by grouping, we're talking about groupings usually of 2. I mean, I suppose you could do it in groupings of 3. But for this one, we're going to focus on these 2. And first up, from the first 2 terms right there, I can see that out of those 2 terms, I can get out a w to the power of 2. I can't factor out any numbers because the coefficient of that first term is a 1. Now, what would be left over? Well, since I took 2 out of those 3 w's, I would be left with just a regular w. From the second term, we still have the positive 6, but I took out all of those w to the power of 2's, so I just have the w plus 6 right there. If we've done this correctly, chances are we're going to end up with the same factor right here in this other term. So I'm just going to point this out, all right? What I'm expecting from the second grouping factored out, I should end up with a w plus 6. I don't know what I'm going to factor out right now until I go into the factoring, but what I notice here is that this leading term in this grouping is a negative, so I would want myself to factor out a negative. And then I would see that I've got a 3 and an 18, which are both multiples of 3, so I can factor out a 3. If I do that, I would take out from the negative 3 divided by negative 3 would be a 1. And from negative 18 divided by negative 3, I would end up with that positive 6 right there. And then, of course, that first term has the w that's still right there. Okay, so I'm not going to show this with the blue parentheses because, again, it came from the red set of parentheses. But from here, it's kind of like what we saw in that last problem, is I now have common factors of w plus 6 and w plus 6, which I can then factor out from the 2 terms, w plus 6, which I'm showing in green now. Whatever's left over will be in this second set of parentheses. So the first term, we have that w squared. From the second term, we have a minus 3. If by chance the 3 were a perfect square, I would be looking at this point to continue my factoring, but since it's not, I'm just going to leave this as is and then call this one good. So this one has been factored out completely by grouping.